Okay, welcome back, everyone. My sincere apologies for breaking this for putting this exam question in a different part. I'd been experiencing some screen share difficulties earlier when I'd been doing the rest of the lesson. But here it is. The question that we were looking at the end of the lesson, towards the end of that lesson, was that light can be described by a wave model, but by also a particle or photon model. The rapid emission of photoelectrons at very low light intensities supports one of these models, but not the other. We want to identify the model that's being supported and give a reason for our answer. Now, the fact that we are dealing with the photoelectric effect should suggest that we are dealing with the particle model. Yes, it might seem tempting to think that even though we're talking about low intensities and how they don't affect how they don't influence the rapid emission of photoelectrons, that might seem tempting to call it the wave model, but it is in fact the particle model. There's a few reasons that you could provide as to why, as to how, you know, mm, as to why why it supports the particle model. One such reason is that you're going to have one photon per electron interaction. So if a photon hits the electron, then one electron is emitted. We discussed this earlier when I said that there was a 1-to-1 ratio between the number of photons emitted and the number of electrons emitted from the surface of metal of the surface of the metal. Another reason that you could give is that the wave model actually predicts an accumulation of energy over time. So the wave model predicts an accumulation of energy over time. So if you keep hitting the piece of metal with waves, then you're gonna constantly have the buildup of energy over time, because waves are simply the transfer of energy without transferring matter. So if you constantly hit something with waves, if you bombard it with waves, you're going to have a buildup of energy over time, and that doesn't happen in this case. Accumulation of energy over time. Okay, so that's since it's a 2 marker, we only need to provide 2 bits of information, and those are the 2 which I have thought of. If there's any more that you can think of, please feel free to add them. The examiner's report for this says that the model supported for this is, the responses that are included are not limited to the ones that are just given in the report. So there's 3 given in the examiner's report. If you look at it, it's available on the VCAR website, but it says that the responses are not limited to these ones. Okay, so that concludes this seminar and on quantum physics. And if you have any further questions or concerns about any of the material that I've discussed here, please feel free to reach out to me by email. I'm just re-plugging that again for anyone who didn't take note at the start. Otherwise, enjoy the rest of VCES. This is actually the last seminar that I'm recording for VCES. So have a wonderful program, and wish you all the best with the with the upcoming year. See you later.